Welcome everyone. Today, we'll explore gauging pigs, what they are, why they're used, and how to interpret their results. These tools play a critical role in pipeline integrity management. Let's start with the basics. What is a gauging pig? Why run a gauging pig? Understanding these fundamentals sets the stage for the rest of the discussion. A gauging pig is a specialized utility pig used in pipeline operations to verify the minimum internal diameter, ID, and detect bore restrictions before deploying more expensive inspection tools. It consists of a pig body equipped with flexible metal plates, typically aluminum or steel, that are slightly smaller than the nominal pipeline ID. These plates deform permanently when encountering restrictions smaller than their diameter, providing a simple yet effective method to identify obstructions or tight bends. Gauging pigs are essential for ensuring that pipelines are free from anomalies such as weld protrusions, dents, or internal coating irregularities that could impede the passage of inline inspection (IL) tools. Their design emphasizes simplicity and reliability, making them a cost-effective solution for pre-inspection verification. The pig body can be made of foam, steel, or urethane, and is fitted with sealing cups or discs to maintain propulsion through the pipeline. The gauging plate is mounted at the front, often bolted securely, and may include multiple plates arranged in a rosette pattern for redundancy and enhanced detection capability. Running a gauging pig serves several critical purposes in pipeline integrity management. First, it acts as a pre-qualification step before deploying high-value ILI tools, ensuring that the pipeline geometry will not cause tool hang-ups or damage. Second, it confirms the passage through valves, welds, dents, and bore transitions, which are common areas of concern in both new and existing pipelines. Third, gauging pigs help identify short-radius bends that may pose challenges for long-bodied inspection tools. By detecting these issues early, operators can take corrective actions such as grinding protrusions, cleaning debris, or adjusting tool selection to prevent costly delays and equipment damage. Additionally, gauging pigs are used after construction to validate bore integrity and detect buckles or ovality that could compromise flow efficiency. Their role in risk mitigation cannot be overstated, as they provide a low-cost assurance mechanism that significantly reduces operational uncertainties. Key components. Materials, plate sizing rule of thumb. The design of a gauging pig incorporates several key components that ensure its functionality and durability. The pig body, which serves as the structural base, can be constructed from foam for lightweight applications, steel for heavy-duty operations, or urethane for a balance of flexibility and strength. Attached to the body are sealing cups or discs that create a pressure differential, propelling the pig through the pipeline. The most critical component is the gauging plate, typically made from flexible metals such as aluminum, 6061, T6, or mild steel. These materials are chosen for their ability to deform under stress without fracturing, providing clear evidence of restrictions. The plate thickness usually ranges from 3 to 6 mm, optimized to withstand operational forces while remaining sensitive to obstructions. Mounting configurations vary, but plates are commonly bolted to the pig's front face, and in some cases, multiple plates are arranged in a rosette pattern to enhance detection accuracy. This design ensures that the gauging pig can navigate complex pipeline geometries while delivering reliable results. Proper sizing of the gauging plate is crucial for accurate detection of restrictions. The general rule of thumb is to select a plate diameter that is 95 to 98% of the nominal pipeline ID. This range accounts for minor variations in pipeline geometry, such as ovality, weld beat heights, and internal coatings, which could otherwise lead to false positives. For example, in a 20-inch pipeline, a plate diameter of approximately 19.4 to 19.6 inches is typical. Operators may also deploy multiple plates with stepped diameters to map restriction thresholds more precisely. This approach provides a gradient of detection sensitivity, enabling better characterization of pipeline conditions. When sizing plates, it is essential to consider operational factors such as bend radii and known internal features to avoid unnecessary deformation that could misrepresent actual restrictions. Operation and interpretation. How deflection indicates restriction, short radius bends, and their impact. The primary diagnostic feature of a gauging pig is the permanent deformation of its gauging plate. When the plate encounters a restriction smaller than its diameter, it bends or creases, providing visual evidence of the obstruction. The pattern of deflection offers clues about the nature of the restriction. Uniform bending across the plate typically indicates a general bore reduction, such as liner collapse or internal coating swell. A localized nick or crease suggests a protrusion, such as a weld bead or debris. Crescent-shaped marks on one side of the plate often point to contact with a short radius bend. To interpret these patterns accurately, operators should record the plate's orientation upon retrieval and correlate observed deflections with pipeline features using construction drawings and run logs. This systematic approach ensures that corrective actions are targeted and effective. Short radius bends, typically defined as bends with a radius of 1d to 3d, where d is the pipe diameter, can significantly influence gauging plate deflection. These bends may cause the plate to scrape against the inner wall, leaving crescent-shaped marks that mimic restrictions. Distinguishing between bend-induced marks and actual obstructions requires careful analysis of pipeline alignment drawings and deflection patterns. In cases where tight bends are unavoidable, operators may opt for guide discs or reduce the plate diameter to minimize false indications. Understanding the interaction between gauging plates and pipeline geometry is essential for accurate interpretation and planning subsequent inspection activities. Launcher receiver setup, safety considerations and operational best practices. Proper setup of launchers and receivers is critical for safe and efficient gauging pig operations. Before launching, verify the integrity of the barrel ID and closure seals, and lubricate as necessary. Install the pig and gauging plate securely, ensuring correct orientation and fastening. Operational steps include isolating the section, depressurizing, loading the pig, pressure testing the closure, equalizing pressure, and initiating launch under controlled differential pressure. At the receiving end, monitor arrival indicators, depressurize, and open the closure following safety protocols. These procedures minimize risks associated with stored energy and ensure reliable pig passage. Safety is paramount in all pigging operations. Key precautions include implementing lockout/tagout procedures and ensuring complete pressure isolation before opening closures. Operators must be aware of stored energy hazards and fully depressurize and drain the system before handling the pig. Personal protective equipment, PPE, such as gloves, eye protection, and gas monitors should be mandatory. Additionally, verify lifting points and use rated equipment to prevent accidents during pig handling. Adhering to these safety measures protects personnel and equipment while maintaining operational integrity. Data management and standards. Documentation and interpretation, applicable standards and best practices. Accurate documentation is essential for leveraging gauging pig results effectively. Operators should record plate specifications, including diameter, thickness, material, and orientation marks. Launch and receive times, pressures, velocities, and any anomalies must be logged systematically. Photographs of the plate post-run, annotated with observed deflection patterns, help correlate findings with pipeline features. This data supports informed decision-making for subsequent inspection or maintenance activities. Integrating these records into asset management systems enhances traceability and compliance with industry standards. Several industry standards govern the use of gauging pigs and related inspection practices. API 1163 outlines qualification requirements for inline inspection systems, emphasizing the role of gauging pigs in pre-inspection verification. ASME B31.4 and B31.8 provide guidance on pipeline design and operation, including pigging considerations. NACE/AMPP SP0102 offers detailed recommendations for geometry verification and cleaning runs prior to ILI. Adhering to these standards ensures operational consistency, safety, and reliability across pipeline integrity programs.